Okay, girls, welcome back. Now, while I was uploading the video, I spotted a mistake. In the previous question, I forgot to put in from assumption in here. Could you make sure you write it down? Or most of you should have already done it. Probably is Gemma. She might be yelling at me. Okay, let's come back to a new question. This is another one in your booklet. Just before we start this, I need to remind you girls, don't forget you can pause this video anytime you want. You don't need to just go straight. Be smart. Okay, this time we have the statement 2 to the power of n greater than 3n squared. Now, let me copy some of the stuff first. So then I don't need to write it again. Okay. There you go. Alright. Test the statement is true for not n equals to 8 in this case. It's n equals, not n equals 1. It should be n equals to 8. Because that's the starting point. So 2 to the power of 8, that is 256. Because 2 to the power of 10 is 1024. And then 3 times 8 squared, that is 3 times 64. 64, 192. Okay, so therefore left hand side is greater than right hand side. Okay, so prove the statement is true for n equals to k starting from 8, and the rest is pretty much the same. So 2 to the power of k is greater than 3k squared. To prove it's true for n equals k plus 1, so 2 to the power of k, 2 to the power of k plus 1, greater than 3k plus 1 all squared. And again, we are trying to prove left hand side minus right hand side. Left hand side minus right hand side is greater than 0. Let's start. Three k plus 1 all squared. And we're going to split this as usual. And then we're going to put in our assumption. Because 2 to the power of k is greater than 3k squared, therefore we do it this way. Okay, so minus 3k plus 1 all squared. Right, from assumption. And then that is greater than 6k squared minus 3k squared plus 2k plus 1. Speed up a little bit now. Expand it, you will get 3k squared minus 6k minus 3. Take it out, that will give us. Now, if you realize this is similar to what we did in the first question yesterday, we have to complete a square for inside in order to make this work, to show that it's actually greater than 0. Now, since k is greater or equals to 8, therefore k minus 1 is greater or equals to 7. And k minus 1 all squared is greater or equals 49. And therefore, k minus 1 all squared minus 2 has to be greater than 0. Therefore, left hand side minus right hand side is greater than 0. So, now I'm going to copy step 4. And you girls cannot be lazy, you need to write it. Oops, it's like this. Oh, doesn't matter. Alright, k plus 1 n equals to k, and it's true for n equals to 8 first. Therefore, it's true for n equals to 8 plus 1 equals 9. 9 plus 1 equals 10. And therefore, it's all for the integer greater or equals 8. Okay. Now, the next question is very, very challenging. this is towards the end question in the Cambridge exercise. I will copy that. So let's get something done first. Oh, no, that's not what I want. I want this. Insert. Question 15 in exercise 6N. Alright, now, first part. We need to prove not with induction. This is general proof of inequality. That's why it can be very difficult. So we're trying to prove root n plus 1 minus root n is greater than something. Excuse me. It's greater than something. That is, it gives us a hint. So therefore, now we need to rationalize the numerator. In other words, we need to make this as non-square root by multiplying top and bottom by root n plus 1 plus root n. And therefore, the top becomes root n plus 1 all square minus root n squared. The bottom is root n plus 1 plus root n, which will give us n plus 1 minus n over root n plus 1 plus root n. And that is 1 over root n plus 1 plus root n. Now, how do we prove this expression is actually greater than this? This is a little bit challenging. Well, kind of, but you need to realize now, whatever at the denominator, the bigger you put in, the smaller the value would be. Therefore, root n is actually less than root n plus 1. So if I replace this root n by root n plus 1, then the total value of this whole thing would become smaller. Does make sense to everybody? I'll say that again. Root n is less than root n plus 1. If I replace this by something bigger, I'll make the denominator bigger. That means whatever or the original would be smaller. Alright, so therefore, if that means 1 over root n plus 1 plus root n has to be greater than this, because I replaced this by a bigger number. And that is 2 of root n plus 1. Therefore, root n plus 1 minus root n is greater than this. Okay, this is only the preparation for the induction question, unfortunately. Alright, let's go to the actual induction. So we need to let the statement be this one. So let me save some time because the actual algebra in this part is a little bit more tedious. I need some time on it. So just let me be lazy for once, and you can't. You actually need to write it. So let the statement be something something. Oh, I don't want this. Anyway, so let the statement be this. Okay? Alright, so therefore, step 1. Now, test the statement is true for n equals to 1. So left-hand side, sorry, 7, not 1. Left-hand side equals 2. Now, be careful. You need to add until 1 on 7, starting from 1. That's the major part. Okay, so it's 1 plus a half plus a third plus 1 on 7 until 1 on 7. All right, and that number blah 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 blah. I don't know what that is. And right hand side is equals to root 7. And root 7 is roughly 2 point something 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 something. And therefore, left hand side is less than right hand side. Somehow. Put it in calculator. I don't have a calculator now. So step 2, assume the statement is true for n equals to k, i.e. assume 1 plus 1 on 2 plus 1 on 3 plus dot 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 until 1 on k is less than root k. Oh, k has to be greater or equals to 7. Okay, now to prove the statement is true for n equals to k plus 1, i.e. to prove 1 plus 2, 1 on 2, 1 plus 1 on 3 plus 1 on k plus 1 is less than 1 on root of k plus 1. Here's the thing. Now, whatever provided for us in the first part is greater than, but what we're trying to prove in the mathematical induction is less than. So it will make it a lot harder for us to use the first part result. So this is the first time I will use right hand side minus left hand side, because I try to make it something greater. In other words, I'm proving right hand side, i.e. prove right hand side minus left hand side is greater than 0. We normally don't do that because I'm just trying to use the one in part A. So in this case, right hand side minus left hand side is root k plus 1 minus the whole thing and that is, if I rewrite this with one more term as usual, and this part is the assumption, and we're going to replace this part by root k. However, the assumption says this whole thing here, whatever underline, is less than root k. So if I replace that, I'm replacing that by something smaller. Does make sense? That means, excuse me, so this is something smaller than root k. So if I replace this by root k is bigger than this. Root k is bigger than this. But I'm subtracting this number, I'm subtracting by a bigger number, so whatever result, leave root greater. And then, that is what we got in part A. Root k plus 1 minus root k. And that should be greater than 1 on 2 root k plus 1. Minus 1 on k plus 1. Again, sorry about that. This should say from assumption. And this should say from part A. And now what we need to do here is make a common denominator, which is 2k plus 1. And this need to multiply by root k plus 1. That one needs to multiply by 2. Okay, now since k is greater or equal to 7, root k plus 1 should be greater or equals to root 8. Just replace it. And root 8 is definitely greater than 2 because it's 2 root 2. And therefore, root k plus 1 minus 2 has to be greater than 0. And therefore, root k plus 1 minus 2 on 2 brackets k plus 1 has to be greater than 0. Therefore, right hand side minus left hand side has to be greater than 0. Again, this is a very difficult question, and then that's step 4. Now, my video is running out of time. Blah, 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 blah. Good luck. Alright, girls, that's it for today's lesson.